Yesterday we had discussed two types of network. In this topology, one is broadcast and another one is non-broadcast. Both network type was working fine in full image topology. In non-broadcast network type, we have to configure a static neighborship. Only this is, the difference. So here OSPF is already running and both interfaces are in area 0. Done. And this is network type on. Loopback interface is point to point. I am going to change it. Interface loopback 1 IP OSPF network type point to point, and I am going to say no to this command. Done. Now again, so IP OSPF interface brief. Here you can see network type is loopback. This router is DR. Okay. Now let me take you to router 2. On router number 2 also, first let me verify the configuration. Yes, Nirav, are you there?
Yes.
So IP interface brief, exclude unassign. So here I have not created loopback. Let me create the loopback interface. Loopback 1 IP address is 20.1.1.1 255.255.255.0 and router OSPF 1 router ID 2.2.2.2 exit interface range F 0/0 and loopback 1. I'm going to enable IP OSPF 1 area 0, let's say. So here OSPF neighborship will soon come up, and on router number 3 also let me configure OSPF. So IP interface brief. So okay, loopback is not 10.1.1.1. Loopback should be interface. Okay, I think this is loopback on router number 3. So here also I am going to change loopback IP address. Interface loopback 1 IP address is 10.1.2.1 255.255.255.0. Done. On this router interface range F 0/0 and loopback 1 IP OSPF 1 area 0. Done, guys. I have configured the OSPF. By default network type is so IP OSPF interface F 0/0 include network type. By default network type is broadcast, and so IP OSPF neighborship is, you can see, full with both router, and there is DR and BDR because network type is broadcast, and you already know on broadcast network DR BDR election append. Okay, and so IP route OSPF, it is receiving both prefix 10.1.2.1 also and 10.1.3.1 also. Okay, in the same way branch offices are also receiving prefixes. So IP route OSPF, you can say it is receiving 10.1.1 via router 1 and 10.1.2.1 via router 2. Done. Here I can configure network type non-broadcast also. So yesterday we had configure broadcast network type also, and now I am going to design this topology as hub and spoke topology. Hub and spoke. I am going to do what? I am going to configure this 2 port as protected port, because there should be no connectivity between these 2 port. There is virtual circuit, here is virtual circuit, here we don't have virtual circuit. So just I want to stop communication between these 2 port. Can anyone tell me how I can achieve this? If I want to stop communication between these 2 ports on this switch, how can I achieve it? Have you heard about switch port protected command? Yes, which command?
Okay.
One command is switch port
protected command I have not heard.
Yes.
It is used to enable the port security.
No, this is different. Switch
This is
port
different.
protected. You see, concept is very simple. In switching we will understand it, don't worry, but concept is very simple. 2 protected port cannot communicate with each other. A protected port can communicate with non-protected port, and non-protected port can communicate with protected port, but two protected port cannot communicate with each other. Okay, so if I will configure these two ports as protected port, so there will be no any communication between these two ports, and this port can communicate with this port can communicate with this port. So now my connection is like hub and spoke. There is one connection, there is one connection. Yes or no? There is no any connection between router 2 and router 3, between branches. So here, as I told you, in hub and spoke topology, your network type should be point to multi-point or point to
Non-broadcast.
multi-point non-broadcast. These two types of network you can configure in hub and spoke topology. First of all, let me configure these two ports as protected to stop communication here, and let me show you what problem will occur if in hub and spoke topology if network type is broadcast. See, here I am going to say config T and then interface range F, not F, E0/1 and E0/2. Switch port switch port protected. Switch port protected. That's it. Now these two ports cannot communicate with each other. If you want to verify, here I can show you. See, I am going to ping 192.168.10.2 means branch 2. See, I am not able to ping. Why? Because router 3 is forwarding traffic to switch 4 to this switch, and switch need to forward it from this port, right? Switch will forward this traffic from this port, but both port are configured as protected, so switch will discard it. Switch will discard it. When you will send traffic from here, source MAC will be the MAC address of this interface, destination MAC will be the MAC address of this interface, because both belongs to same network. Yes or no? And switch have learned MAC address of this interface on this port and MAC address of this interface on this port. So whenever it will receive, whenever we will ping from router 3 to router 2, it will forward traffic to switch, and switch need to forward that traffic from this interface. But these two ports are configured as protected, is not forwarding traffic. Done. Now what is problem here? OSPF neighborship is also down. So IP OSPF neighbor. First of all, can anyone tell me why OSPF neighborship is down between router 2 and router 3? Okay, router 2.
Sir,
router,
LS.
router 2 is sending their hello message.
LSA. Yes. They are unable to form neighborship because of this LSA only.
Okay. And when router 2 will send hello message to switch, switch will not forward that hello message from this interface also. Whatever traffic it will receive on this interface, switch will never forward that traffic from this interface, because these two ports are configured as protected. So here we don't have now OSPF neighborship. Okay, if we don't have neighborship, no problem. What is problem? Still I will receive the prefixes. So IP OSPF database through router 1. See, so IP route OSPF. So IP route OSPF. It is receiving this network still, yes or no? Router 3 is still receiving this network, because router 2 will forward their LSA to router 1 and router 1 will forward it to router 3, because there is one neighborship, yes or no? So there is no neighborship between router 2 and router 3, right? Still router 3 have root for this network, and next hop IP address is, this is problem. Next hop IP address is 10.1.1.2. Oh ho. Yes or no?
So we okay.
Okay. So this router is not ping this IP address.
Okay.
Why? If you will check database in detail, so IP OSPF database. Database of router 1. If you will check database of router, not router 1, database of router 2. So IP OSPF database router and 2.2.2.2. See, I am getting this prefix or not? 10.1.2.1. Yes. But it will forward, you know, router 2 will forward their LSA1 to which router? To DR router. So IP OSPF neighbor to DR router. Who is DR router? Router 1. And next hop IP address will be router interface address 192.168.10.2. And as it is, router 1 will forward it to router 3. Because OSPF does not share route information, it shares LSAs. Inside the LSA, next hop is IP address of router 2. Okay. Here can I configure a static neighborship? Now see the second problem. If my topology is hub and spoke, and let's say by mistake if branch office router will become DR. If this router will become DR, this is second problem. Then what will happen, guys? This router is DR other, this router is DR other. Okay, DR other routers share their database with DR router. Now can router 2 share their database with DR?
No, sir.
No. So this is also a problem. So in this type of network, we cannot configure network type broadcast.
Sir.
Is it clear to everyone? Is it clear, guys? Neerav, is it clear to you or not?
Sir, broadcast we should not configure.
Broadcast we cannot configure here.
Okay, yes, sir. Got.
Got it? Because the topology type is now hub and spoke.
Hub and spoke.
I'm on router number 1 and on router number 3 also. If you want to see, so IP route OSPF. So it is receiving this network. Where is 30 network? 30.1.10.1. Okay, I'm on router 3. So on router number 2. Enable so IP route OSPF. In the same way, when router 2 is receiving this prefix, next hop IP address is IP address of R3. Done.
So then
So
if
here
you
if we-
ping,
What?
yes,
What?
sir.
Tell me.
Actually, last time we tried to ping from R2 to R3, it was
Okay.
not pinging, no, sir.
Yes. From here also, from R2, if you will ping 10.1.3.1 and source is 10.1.2.1. Ping will not work, na? Why? Ping is not working because next
But
hop IP
route is
address is
there,
IP
no?
address of router 3. Yes.
But route is there, no, sir.
Route is
for
available.
10.1.
Yes, you already know how route is available. How route is available because router branch 2 is sending this prefix to router 1 and router 1 is sending to router 2. So
Yes,
route is there, but next hop IP address is IP address of this interface. Because of that, router 2 cannot ping.
So sir, here we need to remove this no IP self hop next hop option, correct? Then they will communicate.
Then also we
via-
have problem if this router will become DR. Then what will happen? Still there is problem. Now if this router will become DR, then router 2 cannot share their database to DR router. Let me show you this. I am going to tell to router number 1. I am going to configure, let's say, priority 0 on router number 1. If I will configure priority 0 on router number 1, then definitely any one router from branch routers will become DR. Yes or no?
Yes,
So
sir.
interface F0/0 IP OSPF priority 0. Done. I am going to set priority 0 on daughter number 2 also. Let's say on daughter number 2 also I am going to say interface F0/0. Router 2 will also not become DR. IP OSPF priority 0. Now which router will become DR?
Router 3, sir.
Router 3, you can verify it on router number 1. So IP OSPF neighbor. Now 3.3.3 is DR. Okay, so router 2 need to share their database with DR router, but router 2 cannot send traffic to router 3. So IP OSPF database. Now see, these are LSA. I am on which router? I am on router number 2, and so IP OSPF database. Here we are able to see router LSA of router 1, router 2, and router 3.
Sir, we are on router 3, sir.
We are on router 3, sir. Yeah.
Okay, yes, we are on router number 3. So IP OSPF neighbor and one neighbor 1.1.1.1, that is DR other. Clear IP OSPF process, let's say, and yes. On router number 2 also I am going to run this command once. Clear IP OSPF process, say yes. So IP route OSPF. So IP OSPF database. Inside the database of router 2, are you able to see any LSA1 of router 3?
No.
No.
So IP OSPF neighbor, I think neighborship is also not in two-way state. Just wait for some time. See, now router 2
No,
cannot
it
share
will be
their.
in two-way state, sir.
Yes, it is in
It
two-way
will.
state. What I am trying to make you understand that router DR router is router number 3. So router 2 will share their database with DR router. Directly router 2 cannot send their database with router number 1, because this is DR
Yes,
other
sir.
and DR other.
Yes.
Yes or no?
Yes, sir. That's why the neighborship is in two-way state.
Exactly. So this is also problem, na? So in hub and spoke topology, we cannot configure network type broadcast as well as non-broadcast. Here network type should be point to multi-point. If I will change the network type, all problem will solve. Okay guys. So first of all, I am going to remove the priority command from all interface F0/0. Say no here, and on router number 2 also, let me remove this command first. Config T interface F0/0, no to this command. Done. And now I am going to change network type. Let's start from router number 1. IP OSPF network type, point to multi-point. Neighborship is done with both router. Now let me configure network type IP OSPF network point to multi-point on router 2, and let me configure it on router 3 also. Config T interface F0/0 IP OSPF network type point to multi-point. Just wait for some time. Okay, now on router number 1, so IP OSPF neighbor. Now here DR and BDR election will happen or not? First of all, tell me that. Network type is now point to multi-point. DR and BDR. No guys, here DR and BDR is no required. There is only 2 number of adjacency you can see here. There are only 2 number of adjacency. Here DR and BDR is not required. That's why DR BDR election will not happen here, right? In this type of network. So show IP OSPF neighbor. See, is there any DR? No. There are two neighbor 10.1.3.1 and 2.2.2. Let me change router ID on router number 3. It's confusing. Router number 3, I'm going to say router OSPF 1 and router ID 3.3.3.3 do clear OSPF process. Yes. Done. So IP OSPF neighbor. Here also we are able to see my neighbor is 1.1.1.1 and there is no any concept of DRBDR. So router 2 will share their database with their neighbor. Their neighbor is 1.1.1 means to router 1 and router 1 will simply share it with router number 3. Getting my point? So here what I can do in this network on router number 2 you can verify it. So IP OSPF neighbor. So neighbor is 1.1.1 and on router number 3 also you can see neighbor is only 1.1.1 and on router number 1 so IP OSPF neighbor there are two neighbor. Okay, soon this neighbor will goes down. This is invalid. Okay, we can say clear IP OSPF process and yes. And so IP OSPF neighbor this time. So neighbor is 2.2.2 and 3.3.3. Now guys see on branch let's say 2 on router number 3. So IP route OSPF. It have received 10.1.2.1 which is running on router number 2 and next hop IP address is IP address of router 1. That means all communication definitely all communication will happen through headquarter. But now I can ping 20.1.1.1 and source is not 20.1.1.1 10.1.2.1 and source is 10.1.3.1. See, ping is working. So in this type of network we can configure network type point to multi-point. There is no any DR BDR. There is neighborship between branch and spoke. Sorry, branch and hub. Between branch and hub. Okay. In full mesh topology, if you will configure network type broadcast or non-broadcast, what will happen? It will. What problem will occur? In full mesh topology, if I will configure network type, in hub and spoke topology, if I will configure network type broadcast, then what problem will occur? Branch offices cannot communicate with each other. Done. Now this is concept of area type. Now we don't have anything network type. Now we have one separate types of network on loopback interface as you are able to see. So IP OSPF interface loopback 1 and here you can see network type is loopback. So whenever we are advertising loopback interface in OSPF, OSPF will configure network type loopback on that interface and we are not we are not allowed to configure network type loopback on any interface. If you will try to configure network type loopback, so see interface loopback 1 IP OSPF network and question mark. Either I can configure network type broadcast, non-broadcast, point to multi-point and point to point. This type of 4 network.
Sir, one question regarding this point to multi-point network
Okay.
type last which you configured. So basically, when you configure point to multi-point on each and every router, router 1, 2, 3, okay, so they are all in the same subnet.
Yes.
All the interfaces, all the three interfaces, L0,
Yes,
0, L0,
are
0.
in the
Okay,
same subnets.
subnet. So what if they are in different subnets? Then also will this particular
See,
point to point?
OSPF neighborship, to form OSPF neighborship, subnet should match. If here subnet is different and here subnet is different, then OSPF neighborship will never come up.
Yes, yes. That is my question because according to this
That's
particular
it.
scenario, no. Actually, sir, according to this particular scenario, it is majorly available in ISP only. Correct?
Yes. So if you are configuring
Point.
OSPF, as I told you yesterday also, that here we have one public IP address, that is 1.1.1. Here I will have one public IP address, let's say 2.2.2.2, and here 3.3.3. Now you can see physical interface belongs to different subnet. So
Different
here we
subnet.
will create one tunnel,
Tunnel.
and on that tunnel
Yes.
I will configure common network
Common network. Yes.
192.168.10.0. This network, let's say /24. So here OSPF neighborship can form. While discussing DMVPN, we will discuss this also. That will be overlay network.
Okay.
In this
Because
course, only you will understand actual implementation of point to multi-point network type in OSPF. Don't worry.
because sir, actually, why I asked this is because in our production environment, I had also seen that we had received one IP, public IP address directly to the router of BSNL.
Mhm.
So we did not change anything, but then also there was no neighborship with the far end router actually. So then we tried changing everything, network type, then
Mhm.
MTU, everything we did,
Mhm.
but then
Mhm.
also neighborship was not coming up. Then
Okay.
finally, what we did is that actually we are responsible till this edge device of the ISP, correct?
Yes, exactly.
So with now that edge device and my interface router should that particular segment should follow same protocols, correct?
Same,
So we
exactly.
yes, so we also shared them our end configuration that we have this particular network type and MTU and everything. Then
Mhm.
also it did not resolve, but then we came to know the issue was regarding the VRF and MPLS.
Okay.
So yeah, so what we did basically was just ISP, IPOSPF and then area 0. That's it. And
Mhm.
default, sorry, we advertise all interfaces directly.
Okay.
So I have not particularly seen this network time being changed in actual production environment, or maybe they don't care. I don't know.
Yeah, maybe.
Because once the other end is reachable, ping is successful and communication is up, so everyone forgets everything.
Maybe. Now we are, going to understand one concept of OSPF, that is virtual link. You already know about virtual link, yes or no, Nirav? You know about virtual link?
Yes.
Why we are using virtual link concept?
Sir, if say for example, as per OSPF, each and every area other than backbone area should be connected to backbone area. So if say example area 2 and area 3 are connected with each other but are not connected with area 0, then in order for the reachability, we configure this virtual link.
Yes. Or we can say directly to extend area 0.
Yes. It
To
will extend,
extend,
but
yes.
it is considered as a kind of a tunnel. But when we do trace route, then it will show all the paths it follows. So basically, but as per
Yes.
Cisco guidelines, it is like they do not guide for this particular configuration. Just for educational purposes,
Yes,
each and every documentation they have mentioned.
exactly. So I was also thinking to skip this topic, but we have time. We can discuss, at least one more topic. And you should have basic knowledge about this topic also. Okay, why we will skip a single topic? Yes or no? Do you
Sir,
want
but
to escape it?
sir, but the same thing which we can achieve via virtual link, we can also do it via, I guess, GRE tunnel. Correct?
Yes. वर्चुअल लिंक तो सबसे फालतू है.
Extra overhead, sir.
Exactly.
सर आप एक काम कर सकते हैं, ये वर्चुअल लिंक के साथ आप जीआरई टनल ही बता दीजिए, खत्म ही हो जाएगा एक ही बार में, क्योंकि आईपी सेक अगर आप पढ़ाएंगे तो उसमें तो आएगा ही आएगा जीआरई.
अभी टनल ही बना दे क्या?
नहीं मतलब काम वही है ना. अब
पहले एक बार वर्चुअल लिंक समझा देते हैं ना.
ओके ओके
देख लो अब थोड़ा सा कॉन्सेप्ट है, आपको भी कुछ नया मिलेगा ही जरूर.
यस यस सर.
Okay, here I am going to design this topology and see what I will do. Let's say this domain is OSPF area 0. Let's say yes, OSPF area 0, and this is OSPF area, let's say 1, and this switch is inside, let's say this area, and then we have one more area, that is, let's say, area 2 or area 3, any other area. Done. So let me write here area 0, area 0, area 1, and let's say this is area 2. So which router will become ABR here? Yes, Rohit, which router will become ABR?
R2.
R2. So ABR router will generate how many types of LSAs?
LSA
LSA 1, LSA 3.
2 and 3.
LSA 1 and LSA 3. Which router will generate LSA 2?
DS.
Is there any router who will generate LSA 5?
No, sir.
4?
No sir. 4 also.
4. Yes, sir. R2 only will generate LSA.
Okay. Good. Okay, let me turn on the device. On R1 interface F0/0 nosat IP address 10.1.1.1 and then 255.255.255.0, and before it let me configure OSPF router ID. Router OSPF 1 and router ID 1.1.1.1. okay, and then interface this interface. Okay, IP address is this one. Here I am going to say exit, then interface F1/0 nosat and IP address 12.1.1.1, 255.255.255.0 exit. After that, guys, I am going to add OSPF command also on this interface. So here I am going to say IP OSPF 1 area 0. On this interface also I am going to add this command. Okay, so I have enabled OSPF on this interface, and this interface there should be exit. IP OSPF 1 area 0. Done. Let me copy this command and let me paste it on router number 1. Enable config T and paste the command. Done. Now let me configure R2. So router ID will be 2.2.2. On F0/0 IP address will be 20.1.1.1. F1/0 IP address will be 12.1.1.2, and on interface F2/0 no set, and IP address will be 23.1.1.1, 255.255.255.0, IP OSPF 1 area 0. Exit. Let me save the configuration as well, and now R2. Okay, so OSPF neighborship will come up between router 1 and router 2. Till then, let me configure router 3. So on router 3, router ID will be become 3.3.3.3. F0/0 IP address will be 30.1.1.1. On fast Ethernet. Oh, on router number 2, I have advertised F2/0 in area 0. But on router number 2, interface F2/0 is IP OSPF 1 area 1. This interface is in area 1, not in area 0. On router number 3, all interfaces are in area 1.
1.
Here IP address is 30.1.1.5. On fast Ethernet 1/0 IP address will become 23.1.1.3, and then IP
Area.
OSPF area 1, and interface F2/0 IP address will be 34.1.1.3, and IP OSPF 1 area 1. Done. Copy it and let me paste on R3. Okay, now let me configure R4. So on R4, router ID will be become 4.4.4. F0/0 IP address will be 40.1.1.1, and F0/0 is in which area? In area 1. Okay, F1/0 IP address will be 34.1.1.4. 4, and IP OSPF area will be 1.
Area 2.
F1/0.
Okay.
And F2/0 area 2, and here IP address will be 45.1.1.4. let's say 45.1.1.4. Config T, and let me paste this command. What happened? Done. Now on router number 5, router ID will become 5.5.5. Interface F0/0 IP will be 50.1.1.1 and IP OSPF 1 area 2, and this interface area 2 and IP address will be 45.1.1.5. right? I'm going to remove this. Come on, copy it and let me paste on R5. Now, will R5 receive 10.1.1.0 prefix?
No.
No. Guys, R5 will receive or not these 10.1. prefixes of area 0? So IP
No, sir.
OSPF neighbor. Now neighborship is full. You can see 4.4.4 is neighbor. Done. But if you will check routing table, so IP route OSPF, so there is no any prefix. Why? Problem is router 4 is not ABR router. Yes or no? Here we need to connect to regular area, and whenever you want to connect to regular area, you have to insert a backbone area between two regular area to connect to regular area. Getting my point? By default, two regular area cannot communicate with each other, like area 1 and area 2. These two are regular area and these two area cannot communicate with each other. Okay. All the router in area 1 will generate their LSA1, and that LSA1 will flood it in this area only. As you know, LSA1 cannot cross area. So in different area, how? Like area 1 will get prefixes of area 0. At how? Because of router 2. Router 2 will generate LSA3. In the form of LSA3, it will receive prefixes of area 0 in area 1. Through LSA1, it cannot receive. Like this two regular area here, LSA1 of this area cannot enter in this area, and LSA1 of this area cannot enter in this area. And this router is not ABR router who will generate LSA3. Okay. So that's why we are not able to see any route inside the routing table of router 5. Okay, let me take you to router number 4. Router number 4. Router 4 will have 10.1.1.0 or not? First of all, tell me that. This. Will router 4 have prefixes of area 0?
Yes.
Yes, sir.
So IP route OSPF. And you can see these are inter-area prefixes.
Yes.
Yes or no?
Yes, sir.
These are inter-area prefixes. That means router 4 have learned these prefixes in the form of LSA 3. Okay. But router 4 will not flood this network information in area 2. Now, what we need to do? We need to extend our area 0 till R4. I need to connect, one virtual link between area 0 and router 4. If I will connect router 4 to area 0 virtually, then this router will become what? ASBR. Or not ASBR, sorry, ABR. This router will become ABR because now one maybe virtual interface is in area 0. Okay. So guys, this is the problem. Because of that, router 5 are not getting these prefixes, and router 1, if I will show you the routing table of router 1, so IP route OSPF. So router is receiving 40 network, router is receiving 30 network, router is receiving 20 network, but router is not receiving 50 networks. Done. Because 50 network is not inside area 1. So what I am going to do, I am going to connect one virtual link between router 2 and router 4. I'm going to connect one virtual link. Now on router number 2, if you will run command show IP OSPF neighbor, how many neighbor are there? So IP OSPF neighbor, let me, how many neighbor are there? 2, 1.1.1 and 3.3.3. Yes. And on router number 2, I am going to run one command, router OSPF 1, and then area 1 virtual link. I am connecting virtual link in which area? In area 1. And after that you need to, yes, IP address of
destination.
4.4.4.4. router OSPF 1 virtual area 1 virtual link 4.4.4.4. and on router number 4 also I need to run this command. Yes or no? Router OSPF 1 and area 1 virtual link 2.2.2.2. After running this command, R2 and R4 will send one unicast message first of all. Okay, and now you can see one more adjacency is there. Now on router number 2, if you will run show IP OSPF neighbor command, so IP OSPF neighbor, now you can see there are 3 neighbor. One is 3.3.3, 3.1 is 1.1.1, and one is 4.4.4. and here you can see interface OSPF virtual link 0. So okay, the things which you need to keep in mind is router sends hello message on unicast address over virtual link. Router send unicast hello message on virtual link. Now router is sending one hello message from virtual link also. So on virtual link it will send unicast message, like OSPF send unicast hello message in case of static neighborship. When you will configure network type non-broadcast or maybe point to multi-point non-broadcast, then you have to configure a static neighborship. And whenever you will configure a static neighborship, then OSPF hello message will be unicast. Done. Actually, once I will configure virtual link on a router, that router will on V bit. Remember, we had discussed 3 bits in LSA1: B bit, E bit, and V bit. We had, you know, I told you that we will discuss about V bit when we will discuss virtual link. So which router will on this bit? B bit? ABR router. ABR router on B bit in their LSA1. E bit ESBR router. And V bit router where you have configured virtual link. Done. V bit represent what here? V bit represent that I am endpoint of this virtual link. Yes, router 2 and router 4, both routers are endpoint. Both will advertise their LSA1 with V bit on. Virtual link work on, you know, demand circuit. If anyone know demand circuit, anyone know DNA? Do not age bit, do not bit. Does anyone have knowledge about demand circuit? No. Okay, so now we will not discuss that. So IP OSPF and then database, I can say a router LSA of 4.4.4.4. Now inside LSA1 of router 4, we are getting this 40 prefix, and okay, I am on router number 2. Let me take you to router number 5. On router number 5, you can see router 5 is receiving all prefixes, and show IP OSPF database. So router are getting, you can see this prefix. Who is advertising?
4.
4.4.4, because so IP OSPF border router. Now router 4 is become ABR router, and cost to reach neighbor is 1, and it will check what? So IP OSPF database, and then summary LSA, and inside the summary LSA, let's say 10.1.1.0. So if you will open it detail, metric is 4. This metric is inside LSA. So what will be the metric inside routing table? 4 plus 1. 1 is the metric to reach ABR router,
Yeah.
and 4 is the metric which is coming in LSA. Yes or no?
Yes.
Is it clear, guys? Now you can see I can ping 10.1.1.1 and source is 50.1.1.1. See, ping is working. Now if you know on TTL link, okay, let me do one thing. I am going to capture this link. Serial not fast Ethernet 2/0. Let me copy this link. And just I want to show you. Who is sending this hello message? Router 2. On what address? On this address. I want to check, you know, hello message which router is sending on. Virtual link. On virtual link, hello timer is what is hello timer on virtual link, guys? Debug OSPF IP OSPF packets hello. We are not able to see unicast hello message in capturing now. Receive one hello message from okay. Is this router sending any unicast hello message to 4.4.4? What is the IP address of 4.4.4? Okay, how router 2 will find IP address of 4.4.4? It will run command on all. It will run this command. So IP OSPF, after that database, and router 4.4.4.4. Here it will find the IP address of 4.4.4 inside this LSA. IP address of router interface. This is IP address of which router? Router 4. And what is the cost to reach this, you know, neighbor 2 from R2?
Yes.
But why we are not able to see unicast hello message here? Okay, maybe on virtual link packet I am not capturing here. It's not capturing, but all virtual link traffic will also flow from the physical interface only, so it should capture it. Okay, no problem, fine. Now actually I want to show you two things. Whenever it is sending, see, hello message, let's say. So inside the hello message, see, this is IP header. Inside the IP header, TTL value is what? 1. Why TTL value is 1? What is the benefit of it? When routers are sending their hello message, they have set TTL value 1. What is the reason? Reason is security. Yes or no? If TTL is 1, let's say here router 2 is connected with one attacker router. So when router 1 will send hello message, it will send that hello message to attacker router also. Attacker will also form OSPF neighborship here. Yes or no? Yes. So that's why here we have set TTL value 1. So when
single hop,
router 2 will receive it, it will not forward that hello message to any other neighbor. Yes or no? Because TTL value will become 0. But when router send hello message on virtual link, it will set TTL value 255. Right? So here we need to run one command. Whenever we are configuring virtual link, we need to run one more command, like on router number 2 and on router number 4. A router OSPF 1 and then area 1, say virtual link 4.4.4.4, and then I think TTL security. And here you should find what TTL value should be set in the hello message. So what should be the TTL value? 2. So we will set 2 only. So this is very important command you have to run manually on router. Hop 2. This is the command. Okay, again OSPF neighborship will come up. Done. So now it will start sending hello message with TTL value 2. So you have to find how many hops are there between two endpoint of virtual link. Done. After that, if you want to configure authentication on virtual link, so you can configure authentication also. Before that, let me run this command on router 4 also. TTL value config T and router OSPF 1 area 1 virtual link 2.2.2.2 and TTL security hops 2. Done. Now if you want to configure authentication here, we will discuss authentication in OSPF also. Let me make you understand the authentication on virtual link only. A router OSPF again 1, and then we will say area 1 virtual link 4.4.4.4 and then authentication. Okay, like this we can configure authentication also. Message digest MD5 authentication. Done. And then we can configure the key area 1 virtual link 4.4.4.4 and authentication. Then we can say what? Authentication key Cisco 123. Now OSPF neighborship bill goes down. Yes or no?
Yes.
So because you have to configure
Same.
authentication on both router. Yes or no?
Yes. Same key and same hashing algorithm.
Yes. Authentication type and authentication data should be same.
Same.
Done. So I think these are concepts of OSPF. We have covered all concepts. Now we have only we need to discuss only filtering parts, filtering and redistribution. Guys, here filtering will be little bit different in OSPF, because here routers are exchanging LSA, not routing table or routes information, right? Like if you remember, in EIGRP we were filtering prefixes with source IP address, that whenever I was a topology like this, router 1, then switch, then router 2 and router 3, here I have one router and we have some prefix here. Yes or no? Now if I want to filter some prefixes, let's say X prefixes via router number 2, so I can define source IP address, what IP address of this interface. Yes or no? But if in OSPF you are doing same thing, you are filtering a prefix X network, right, via router number 2, so next hop IP address will be what? Advertising router ID of router 2, because router 2 will share their LSA with what source? In EIGRP it will send with this IP address as source IP address, but inside the LSA advertising router ID will be the source. So advertising router ID will be the router ID of 2.2.2.2. So here you will match this source, not the IP address of this interface. Yes or no?
Yes.
So like this, there are some difference in route filtering in case of OSPF from ESGRP. Don't worry, we will discuss everything, all possibility for the route filtering or for the path manipulation in OSPF. So from tomorrow we will start path manipulation. I need to design one topology also for that. So I will design one topology and then we will discuss. So now we have covered all parts, all important topics and not important